Today you're going to be able to write and graph an equation of direct variation after the video. The main thing we want you to understand during this video is this fancy word here, a word you are already familiar with, proportionality. And that's a long word, but let's think. Root word, proportion, which is something you are already familiar with in math. So let's look at direct variation. You may want to take some time to get these notes into your notebook. Pause the video where you need to. The first thing you need to understand is the vocabulary word direct variation. Direct variation is a relationship that can be represented by a function, and we've talked about that before, in the form y equals kx, and k cannot be 0. So let's take a moment and review the word function. Sorry, I can't make an error. The word function. Remember, function is for every one input, there's exactly one output. You cannot have any repeating x values. K is the constant proportionality, also known as the slope. So that's just another way of saying slope. And we talked about slope. Slope is rise over run. Slope in the equation is the letter m. Slope is also called the unit rate. There are a lot of words that represent slope. So continuing, unit rate is a rate with a denominator of 1. If a store sells 2 shirts for $25 and a store sells 3 shirts for $30, which one has a better unit rate? What could you do? You're going to find the proportion or create a proportion to figure out which one has the better buy. And it looks like the second store. Here the constant variation is the amount of each shirt. That's all. You're looking for the unit rate. So let's continue. Does the equation represent a direct variation? If so, find the constant of variation. Well, here are some steps to see. Again, you may want to get these in your notes to see if this equation represents a direct variation. The first step is to get the y variable alone. Remember a while back, a long time ago, not really, but this school year, we solved literal equations. That was the purpose of doing it first, because from that point on, you will see equations that have more than one variable. Here you have a y and an x, and it says to get the y alone. Is that y alone? No, it is not. Why not? Because there is a 7 with it. So we need to get it by itself by dividing. Y equals 2 over 7x. Simplify. That's the second step. I don't need to. I'm done. And the last, does the answer form look like this? Y equals kx. Well, let me go see. Y, yes, equals, yes. K, the unit rate, yes. X. That equation does represent direct variation, and the constant proportionality, also known as the slope, is 2 over 7. It is that simple. Let's look at another example. Does the equation represent a direct variation? If so, find the constant of variation. Does it? Again, we have to have it in form y equals kx, and here it is not. So I am going to move the 4x to both sides. I cannot combine them because the 8 doesn't have an x. And to get the y by itself, I have to divide by 3. This equation does not look like y equals kx. Therefore, it does not represent a direct variation. Here's another example. Suppose y varies directly with x and y equals 35 when x is 5. What direct variation equation relates x and y? What is the value of y when x equals 9? Whew, that's a lot. So let's break it down. I already know it's a direct variation because it tells me. Suppose y directly varies with x. So it is a direct variation. Well, I got some steps. Step 1, start with the function form y equals kx. Substitute for x and y, and then solve. All right, so y is 35, because it told me to substitute. We don't know k, but we know x is 5. Solve. So what variable am I solving for? Solving for k. Divide both sides by 5. 7 equals k. Then it says write equation using new value. So y equals 7x, because that is my new value. And then it says, what is the value of y when x is 9? What am I going to do? I know x is 9. I'm going to substitute it into my new equation. Y equals 7 times 9, which is 63. And that is my value. We're keeping this very, very simple. Here's another example. Suppose y varies directly with x and y equals 10 when x equals -2. What direct variation equation relates x and y? What is the value of y when x equals -15? Again, I already know it's a direct variation because it tells me here. So substitute the values going back to my notes. Maybe you paused and wrote them down, but it says start with the function form of y equals kx and substitute. So y equals kx. 10 is y. Don't know k, and I know -2 is x. Divide both sides by -2. -5 equals k. So my new equation is y equals made a boo-boo. Y equals -5x, and I want to know what my value is when x equals -15. So -5 times -15, and I get y equals 75. That is literally it for direct variation. If you have any additional questions, see your teacher. Hope this video helped, and again, document notes into your notebook.